If you're a developer, you know AI coding assistants are completely changing the game, right? They're like having a super-powered pair programmer on call 24/7, helping us write better code way faster. But what if that helpful assistant had a really dangerous blind spot? Well, some new research suggests that the very tools we trust to build the future might have a fundamental flaw that could put everything at risk.
I mean, think about it. From auto-completing entire functions to helping us debug the gnarliest problems, these tools are just everywhere now. They're baked right into our IDEs and have become a totally indispensable part of the modern software workflow. We've really come to trust them, to rely on them, maybe a little too much.
Because you see, some new research has just uncovered a pretty chilling reality. The very features that make these AI assistants so incredibly powerful can actually be turned against us, creating a new and seriously widespread threat. So let's talk about IDEaster. And no, it's not a single bug, it's a whole new class of over 30 security flaws discovered by researcher Ari Marzouk. This thing affects a ton of popular AI IDEs, and the impact? Well, it's severe. We're talking remote code execution and data theft. But the craziest part, the core finding, is that it weaponizes legitimate IDE features that we've all considered safe for years. So yeah, this isn't a problem with just one specific tool. This is a systemic issue found across the board in major AI IDEs and extensions. Think GitHub Copilot, Cursor, Zed, you name it. In fact, 24 of these vulnerabilities have already been assigned official CVEs. And if you know what that means, you know it's serious. These are recognized, documented vulnerabilities. This is very real, and it is widespread. So the big question is, how is this even possible, right? How can these tools that we trust so much suddenly become weapons? Well, the answer lies in a really fundamental flaw in how they were designed. You know, as the researcher Ari Marzouk puts it, the heart of the problem is a broken threat model. For years, IDE features like, say, writing to a settings file were considered safe. Why? Because a human developer was in control. But the moment you introduce an autonomous AI agent that can do those same things without any user interaction, the whole game changes. The AI doesn't have our human context or caution, and that creates this dangerous gap that attackers are now figuring out how to exploit. Okay, so how does an attacker actually pull this off? It's not just one single action. It's a really clever chain of 3 distinct steps all working together. So the attack unfolds in what's being called a 3-vector chain: hijack, act, and weaponize. It all starts with an attacker hijacking the AI's context. Then the AI takes autonomous action based on those malicious instructions. And the final critical step is when it weaponizes a totally normal IDE feature. You know, each link in this chain might seem kind of minor on its own, but when you put them together, they create a really powerful exploit. Let's break that down real quick. First up, context hijacking. The attacker uses prompt injection, maybe through some hidden characters in the code, a malicious URL, or even a poisoned server, to feed the AI bad instructions. Step 2 is autonomous action. The AI, which has now been hijacked, thinks it's just being helpful and performs actions using its own tools, often with auto-approval, so no human is even looking. And finally, step 3, feature weaponization. The AI abuses a legitimate, trusted function like writing a file or changing a setting to do the attacker's dirty work. Okay, that's the theory. But what does this actually look like in the real world? Well, the consequences are pretty much exactly what you'd fear: stealing your most sensitive data and running malicious code right on your machine. Let's look at a real example of data theft. An attacker could trick the AI into reading a sensitive file, like your .env file where you probably store secret API keys. Then the AI is told to create a new JSON file. But here's the trick. This new file is crafted to reference a remote JSON schema, basically a file that defines its structure, and it's hosted on the attacker's server. The IDE, just trying to be helpful, automatically goes to fetch that schema, and in doing so, it leaks the contents of your sensitive file right in the URL of the request. It's so subtle, but absolutely devastating. Now, this next one is even scarier: remote code execution. Here, the AI is instructed to edit a core IDE configuration file, like settings.json. It then overwrites a critical path, let's say the path to your PHP code validator, and points it to a malicious script instead. The very next time a routine operation like code validation gets triggered, boom, the IDE unwittingly runs the attacker's code. What makes this so dangerous is that a lot of these AI agents are set up to auto-approve file writes in the project's workspace by default, meaning this can all happen silently with zero user interaction. And look, this is not just some theoretical threat.
This table right here shows specific, registered CVEs for data exfiltration and remote code execution across major platforms that you're probably using right now: GitHub Copilot, Cursor, Zed.dev. The fact that these attack chains work everywhere really shows this is a systemic issue and how AI agents are interacting with the applications that host them.
So, the crucial question is, what can we do about it? The good news is there are concrete steps we can take, both as the people using these tools and as the people who are building them. For us users, it really comes down to three things. First, treat your projects as trust boundaries. Only use these AI tools with code and files that you absolutely trust. Second, vet your connections. Only connect to trusted servers and keep an eye on them. And third, manually review any context you add to the AI, especially if it's coming from a URL. You gotta look for those hidden instructions. Now, for the builders of these AI tools, the recommendations are a bit more architectural. They need to apply the principle of least privilege. Don't give the AI tools more permission than they absolutely need. Harden the system prompts against injection. Sandbox all command execution. And most importantly, they need to be doing rigorous security testing specifically for these kinds of AI agent interactions. All of this really points to a bigger idea. The researcher is proposing a totally new security paradigm called Secure for AI. It's all about moving beyond just secure by design and actively thinking about how autonomous AI components could be abused down the line. It's a fundamental shift in mindset, really. So let's wrap this up. Here are the key takeaways. 1. IDEsaster is a new and very serious class of attacks. 2. The root cause is this unsafe combination of autonomous AI with legacy features that were never built for it. 3. We need to mitigate this now, both as users and builders. And 4. We've got to adopt a secure for AI mindset to build the next generation of software safely. And this leaves us with a really critical question for the future. As these powerful autonomous agents get embedded into everything from our code editors to our browsers, our whole approach to security has to evolve with them. It's not just about patching bugs anymore. It's about fundamentally rethinking what trust even means in a world where our tools can think for themselves.